7.14. A. Okay, let's see. So we have 9y 0 over here minus 6 cos bx. Let's do this in blue. No. So this is the complementary equation. Minus b plus minus b square minus 4ac, but these two cancel out, so I'm just left with 9 because there's no minus 4ac. Over 2 times a. So 9 minus 9 is 0. So either the solution is 0 or it is 8 or it is 9. But then we have yx is equal to c1, just c1, because it's e to the power of 0, and then c2 e to the power of 9x. E to the power of 9x. And now the general solution. The general solution yp, a particular solution may have the form a cos bx. The derivative is a sin bx. The double derivative is no, I have to, well, I forgot the inside. Yeah. So minus a b squared cos the derivative of the outside and the derivative of the inside. Now what? Now, if we put this particular solution back into the equation, we have minus a b squared cos bx. This will become positive 9. And then we have, but the thing is yp is 0. Yp, or is it? Did I get this wrong? Oh, I'm treating this as a wait, I got the entire thing wrong. Got this thing wrong. Plus 0 y. This is wrong. So yp is this, the double derivative. Okay. Wait, lambda square. It's lambda minus 9 is 0. So let's try to solve this. The complementary equation is And then we have 0, 0 square minus 4 times A times C. 4 times A minus 4 times A times C over 2 plus and minus 6. So plus and minus 3 over 2. Sorry, plus and minus 3. So 3 and minus 3. Sorry, I was gone for I just had to do something. So anyways, this is the solution for the complementary equation. This is a particular solution for the mean equation we are finding. Now we want IP derivative, double derivative. Now we want to substitute this into that. Yeah. So we have minus and then we have 0 and then we have minus 9 A cos B x. This is not 3x, this is bx. This gives minus 6 cos 3x. So it makes sense to let b equal 3. Yeah. B 3b 9 3 3. And then we have 9a. So this appears 2 times and becomes minus 18 a cos 3x is equal to, I can remove the minus, 6 is equal to 18a, which implies that a is equal to 1 over 3. Is that right? And then we have substitute in this here. We have a particular equation and then C1 e to the power of 3x plus C2 e to the power of minus 3x plus cos x over 3. So just for a alone, it's true. So it works. Question B. X double derivative of x plus 2 derivative of x plus x equal 4e to the power of minus t. So seems correct. Now let's try the solution first. Whoops. Minus 4ac. But that's just 0. Divided by 2, and that's 1. So the solution is e, so x, c1e plus a the power of t plus, I think it's this, right? Hold on, let me check the thing. The last chapter. I can't. So, anyways, before I check that, the particular solution would be of the form a e minus t, right? Just want to check their summary. And the derivative of this, it's not y, I keep forgetting. X, derivative of x with respect to t minus a, this remains the same. Oh yeah, and there's a C2 over there. So we have this. We substitute this back into the original equation. So we have this plus, actually minus 2 a plus a gives you 4e to the power of minus t. This plus this is positive 2. This plus 2 minus 2 is 0. 0 is equal to 4e to the power of minus t. And then we have an issue. So what do we do in such a case? Okay, let's try some other equation. T times, and how did they derive it? They do, okay, they did what I think they did. a t. So first, let's take a out. First derivative. So we have okay, derivative of the first, which is just t times the second, less the first times derivative of the second. First times the derivative of the second. Derivative of this is minus a. And then this entire thing, this thing is like this, right? So I just copy this entire thing. This minus this minus 2 plus t. Um, so substituting that in, minus t 2, and then we have 2 times this, so plus 2 times e to the power of minus t minus 2t a e minus t. Oops. Plus plus 80, which is 4 e minus t. Now what? I think I instead of never mind. Actually, yeah. I might. Instead of this, we type this. And then this. So hold on. This plus this will give 280 to the power of minus t, and then it cancels out with this over here. But this and this also cancel out, so we have made no progress. Okay, let me see what the issue is. Derivative of the first times the second. That's the first times the derivative of the second. This is just this. Minus derivative of the first times the second. The first times the derivative of the second. So we have this and this minus 2, okay, plus this. Did I make a mistake somewhere? So this remains, and then plus 2 uh okay, I have to look at the solution. Based on the form, our initial guess for the particular solution is this. Well, we see that this guess solves the complementary equation, so it must be so we must multiply by t, which gives a new guess, at e to the power of minus t. Checking this new guess, we see that 2 solves the complementary equation, so we must multiply by t again, which gives this. Okay, so if it solves the complementary equation, check whether any term in the guess for yp is a solution to the complementary equation. So my guesses for yp cannot solve the complementary equation. If it does, then I have to make another guess. So instead of at, I now have to guess at square. So derivative of the first times the second, 2t ae minus derivative of the first times the second plus the first times the derivative of the second. We are left with this. And now, okay, hold on. I think it's easier if I do this. So derivative of the first times the second plus the first times the derivative of the second, which is 2 minus 2t. Wait a minute. I can extract this out. So this minus this like that, right? 2 minus 2t. I can take a to the power of e minus t separate. So I'm left with this minus this, right? Minus 2t. 2 minus 4t plus t square gives me imagine I do all that and the answer is wrong. Let's just skip this. Double derivative 2a, let's see. So 2a e to the power of minus t minus 4t and 8t square. Minus 4t and 8t square. Now we have to substitute that in back to here. square plus 2 times all of plus 2 times that, right? So I will 4 and minus 2. And then plus x. So plus x plus x. So a times e to the power of minus t. Let's take this out. We took this out. This plus this plus this plus t square. So this plus this plus t square. Now t square will cancel out with minus 2t square. T and t will cancel out. We are left with 2. Is that right? 2 a e minus t gives you 4e minus t implies that a is 2. Did that solve? A is 2. Yes. Yes.